Hello everyone, just want to take a look at some of these questions here from the M2 homework. First of all, sketching a pulley with arrangement that gives a mechanical advantage of 1. Well, this really only should have one rope other than the one pulling it. This will be a mechanical advantage of 1. Whereas something with 2 ropes lifting other than the one pulling it, this will have a mechanical advantage of 2. Okay, question number 2. If you want to have a winch of mechanical advantage of 4 and the radius of the axle is 5 centimeters, this is a load arm. Well, in this case, the mechanical advantage is equal to the length of the input divided by the length of the output. So that's 4 is equal to L over 5. So in order to get L by itself, you're going to multiply both sides by 5. So 4 times 5 is equal to L, or L is equal to 20 centimeters. Taking a look at the third question, mechanical advantage of this pulley system, you see 1, 2, 3, 4 ropes that are lifting, and therefore this will have a mechanical advantage of 4. Question number 4 says if 2 sprockets, combination of gears, well, you will have two gear systems in front, 4 gear systems in the back, and this smaller one can combine with any of these 4, and this larger one can combine with any of these 4. So that would be a total of 8 possible gears. Number 5, design an experiment that tests the advantage using a mechanical system to lift a bucket of cement to a height of 1 centimeter. Use a mechanical system of your choice. So really, key thing here is that design experiment tests the advantage of a mechanical system. Really what you're looking for is to determine the mechanical advantage. And it doesn't matter what you've got, but you're going to figure out how much force is required to lift, usually with a spring scale. And then you're going to use it through your system, maybe a pulley system or whatnot, and you'll use that also with a spring scale, and you'll find the mechanical advantage using mechanical advantage being the load on the output, that's that overall force, divided by the load on the input. This is with the system. And that will be how you would determine the mechanical advantage. Okay, so taking a look at page 19, question number 1, we've got work is equal to force times distance. So that work is that force is 12 newtons, the distance is 5.6, and so you've got 67.2 joules of work happening. Taking a look at number 2, the mechanical advantage here. Mechanical advantage is going to be the length of the input divided by the length of the output, which means the mechanical advantage of 210 centimeters divided by 25 centimeters at the load gives you a mechanical advantage of 8.4. Now, in question number 3, to lift 4 kilograms of books means that the amount of force required, because you're lifting it, 4 times 10 means 40 newtons of force is going to be required. Now, we've got the 5 joules of work. Distance, 5 joules of work is equal to 40 times d. So you'll divide both sides by 40, so 5 divided by 40. That means the distance is 0.125 meters, or 12.5 centimeters. Taking a look at number 4, in the case of number 4, the mechanical advantage, in this case it's force on the output divided by force on the input. Now we've been given a mechanical advantage of 2. We're looking for how much comes out. We're at the load where we're putting in 7.5 newtons of force at the effort or input. And so 2 times 7.5 gets a total of 15 newtons in this pulley system. Number 5, mechanical advantage is equal to the length of the input divided by the length on the output. Mechanical advantage, length of the input divided by length of the output. Here, the input is that 0.5, that's the handle, that's your input, divided by 0.21, which means the mechanical advantage. Mechanical advantage, therefore, is going to be 2.4. In question number 5, the force on the output is going to be 35 kilograms multiplied by 10, so 350 newtons, because we're assuming we're on Earth. And so mechanical advantage, again, is going to be the force on the output divided by the force on the input. That's going to be 3 is equal to 350 divided by the force on the input, because we want to know how much force we're putting in, or force on the input is equal to 350 divided by 3, or 117 newtons to the nearest whole number. Taking a look at number 7, the speed ratio is always the number of teeth on the following gear, the driving gear, divided by the following gear. And so in this case, you've got 30 teeth on the front gear of the driving gear, 11 teeth on the back. So the speed ratio is 2.7. What that means, if we think about this, is that the following, if this is the driving gear, the following gear spins 2.7 times for each time the driving gear spins. I should have that going in the opposite way. So this gear is going to go once, the following gear goes 2.7 times, or 2.7 times faster. Taking a look at number 8, if this therefore is the driving gear, well, we've got 12 teeth on this one, and this being the following gear, and you count the number of teeth, you're going to find that it is 20. So speed ratio, being the driving divided by the following, means that that's going to be 12 divided by 20, or a speed ratio of 0.6, meaning that this is going 0.6 times slower than this one. Well, what happens if we've got a speed ratio of 8 and the driving gear has 32 teeth on it, which means that you've got 8 is equal to 32 over F, or F is equal to 32 over 8, which means the following gear would only have 4 teeth. Now I know that is not a very reasonable question, but it is the one that we have with the information we've been given. Number 10 here, two-step problem. Step 1 is to find that mechanical advantage. We're going to use that given the lengths. That's going to be the length on the input, or effort, divided by the length on the output, or force, which means that the mechanical advantage being 11 over 22, or a mechanical advantage of 0.5. Now that we have the mechanical advantage, we can use that mechanical advantage to find the force on the input, which is what we're looking for. So 0.5 is equal to 2 over the force of the input, or force on the input is equal to 2 divided by 0.5, which means it's 4 newtons of force. Lastly, we're just trying to find what the mechanical advantage is of each of these 3 pulleys, and really it's just counting the number of ropes other than the rope that we're pulling on that's used to lift the object. So this is 1, 2, and 1, 2, 3. So this has a mechanical advantage of 1, this is a mechanical advantage of 2, and this has a mechanical advantage of 3. Hope this helps in terms of understanding all of the homework.